title is the time response analysis and design. So in the time response analysis and design, we have two types of inputs which can be applied to a control system. One is command input or reference input, that is Y R of T, and we have the disturbance input W of T. So this is an external disturbance. We have typically uncontrolled variations in the load on a control system. In system controlling, for a system mechanical motion, we have a load disturbance, maybe represented by forces. So in the voltage regulated system, we have variations in electrical load area, which have the major sources of disturbance, which comes under the time response analysis and design. So when we are looking after into the transfer function, we have one types of modeling as a system, and we have using the first principle, which has the differential equation is obtained, and if it is a Laplace transform is applied to the equation, it is assuming a zero initial condition. And if you have a ratio of Laplace transform output to the ratio of Laplace transform input, it is expressed as a ratio of polynomial in S in the transfer function. So in connection between the T and S domain, we have to consider the input system, that is X of T and Y of T, those as a dynamic model as the form. So you can see in the slide we have the formulas for trans, and we have also have a defined value for a characteristic equations. So if it is a Poisson zero definition, that is in an input to output system, that is if it may be x of t or y of t, whose transfer function has the form, that is y of s or x of s, which we have, you can say at a system that is g of s. If we are cross multiplying it, we can get the y of s equal to g of s into x of s. So that is equal to b of s by a of s. The poles are the values of s, for which a of s equal to 0, and the values zeros are the values of s for which b of s equal to 0. So what is the order of the system? The order of a system is given by the order of a differential equation governing the system. Apparent Alternatively, it can be ordered by obtaining from the transfer function. In the transfer function, it has the maximum power of s in the denominator polynomial, gives the order of the system. So what is the dynamic order of the system? That is, if it has the order of the system is the order of differential equation that governs the dynamic behavior. It has the working interpretations, and it has the number of dynamic elements, capacitance or hold up elements between a manipulated variable and a controlled variable. So it has the higher order system response are usually very difficult to resolve from one another. The response generally becomes less sluggish as the order decreases. In the system response, we have first order system response and second order system response, which consists of transient and steady state. So if you are considering the first order system, to have a system that is like k constant value or a gain, and t is a time constant, and we have 1 by 1 plus s of t, and it has the value of 1. So in the first order system, we have a derivation, which you can see in the slide, that is output by input, that is C of s by R of s equal to 1 by 1 plus T of s. When you are applying the R of s as 1 by s, then the C of s, we will get the C of s equal to 1 by s into 1 by 1 plus T of s, where the R of s will be cross multiplied and R of s is as be substituted as 1 by s. So when we are applying the step input signal, you will get the response of unit step input. Here you can see the ratio, that if it is 0 for a t, you will get 0.632. If you are having a 0 to 2t, you will get the value of 0.865. So by applying the value of 1, ts 1, 2, 3 and 4, you will get the values. So this is the first order system, how it have been generated. You can see the in the diagram, the first order system will be converted into this stage by applying a negative feedback system. It will converted as a 1 by 1 plus T of s. So the output will be C of S by R of S equal to 1 by 1 plus A of S. It is the final value. Then after converting, you have to take the partial fraction expansion, that is C of S equal to uh, 1 by T, that is divided by S into S plus 1 by T, that is equal to A by S plus B by S plus 1 by T. When A is obtained by multiplying C of S by S and letting S equal to 0, so by if you want to find out the A value, then you have to substitute the S equal to 0, and you have to substitute the C of S value individually.